Good day everyone, this is Ma'am Jo and welcome to our video lesson discussion in Basic Calculus, and our topic is implicit differentiation. In our previous lessons, so far the functions that we have discussed explicitly state the relationship between two variables, such as the following examples. However, there are other equations wherein the relationship between the variables x and y are implied or expressed implicitly, such as these examples. What do we mean by explicit and implicit? If we're going to look at the meaning in the dictionary, when we say explicit, the statement is complete and very clear. So you will directly understand the message or what is being expressed. Okay? It will leave no doubt about the meaning or the message is revealed. Okay? You will understand directly what is being stated or what is being said. But if it is implicit, that we have what we call the implied message. So the message is not directly being stated. That's why it is vague or malabo, unclear. Okay? You can understand it, you are capable of being understood from something else, though it is unexpressed. Maiintindihan nyo siya, pero hindi directly nyo maririnig yung ibig sabihin. Alam nyo na iyon ang sinasabi niya, pero hindi niya directly sasabihin yon. That's why the message is implied, or the direct message is hidden. Okay, it is implied. Now if we're going to relate that one, explicit and implicit in mathematics, we are talking about the relationship between the variables x and y. So here in explicit, you will notice that y is expressed in terms of x. There is only one variable on the other side of the equation, and we can say that these are functions and the relationship is 1:1. However, in implicit, y is not, the relationship between y and x is not clearly stated. Here, y is expressed in two other variables. So, meron ka ng y dito, si y dito meron pa ulit na naka-times kay x. So, we cannot see the relationship directly. There are two more variables or in the expression, okay? You cannot see directly the relationship between those two variables. So that is the difference between explicit function and implicit equation. Let's take a look at this equation of a circle. X squared plus y squared is equal to 9. So here, the value of y is not explicitly written. But if we're going to solve for the y value, it will give us two explicit equations. Okay, two values. So, transposing x squared to the other side and then getting the square root, we will have two equations which is equal to y equals to the positive or the negative square root of 9 minus x squared. And if we have two values for y, we know that this one is not 1:1. The relationship is not 1:1. Okay, there are two values for y. However, we can still get the derivatives of this by using the chain rule. But we will not be using the chain rule, but instead we will have another way of finding the derivative of an implicit function, and that is what we call the implicit differentiation. To define it clearly, so when we say explicit function, it is an expression containing only independent variable, just like these examples. Okay, so there is only one variable on the other side, and y is expressed in terms of x. Okay, for implicit function, so it is an expression in which dependent variable and the one or more independent variables are not separated on opposite sides of an equation. So these are the examples. Okay, so it contains two or more variables on the other side, and the relationship is not clearly defined. Okay? So what is implicit differentiation? So we define this one as the process of finding the derivatives of the dependent variable by differentiating each term separately, or by expressing the derivative of the dependent variable as a symbol and by solving the resulting expression for the symbol. Okay, and this will be the procedure. So given an equation that defines y implicitly as a differentiable function of x, there are two steps to follow in order to solve for dy dx. Okay, first, we have to differentiate both sides of the equation with respect to x. So always we can use the chain rule when differentiating terms containing y. And the second step is to solve for dy dx. Okay, let's have an example. Differentiate for x squared plus y squared is equal to 16. So the first step is to differentiate both sides of the equation or every term in the equation. So we'll get the derivative of 4x squared, y squared, and 16. Okay. Now, for applying the rule for differentiation, so the derivative of 4x squared is 8x. And for y squared, we will have 2y, but we will attach the dy dx. So, pagka y ang kinukuha nyo yung differentiation, lagi nyo lang inilalagay after you differentiate the term, yung dy dx. That is applying the chain rule. And then for derivative of 16, that will give you 0. And then we solve for dy dx. Since this is the term containing dy dx, so we have to isolate 8 in one side of the equation. So we can transpose 8x to the other side, and that will give you 2y dy dx is equal to negative 8x. And then solving for dy dx, we will divide both sides by 2y. So we'll have this equation, and then we can simplify this one. Negative 8 by 2 is we can simplify it. That will give you negative 4x over y. And this will be the differentiation or the derivatives of this implicit function. Did you follow? Okay. Okay, let's have another example. Differentiate x squared minus x minus y is equal to 6. Applying the procedure, the first step is to differentiate both sides of the equation or each term of the equation. So we will have the derivative of x squared minus the derivative of x minus the derivative of y equals the derivative of 6. Applying the rules for differentiation, so the derivative of x squared is 2x, derivative of x is 1, and the derivative of y is also 1, and then we attach dy dx. And then derivative of 6 will be 0. So we'll have this expression. Now, solving for dy dx, that is our second step. So simply transpose this one so that it will become positive, and that will give us dy dx is equal to 2x minus 1. And this will be now your answer. Did you get it? Okay. Okay, let's have another one. Differentiate x times y is equal to 1. Okay, for this one, we have here a product. Okay, so if we're going to get the derivative of this, we will apply the product rule. Okay, can you still remember? Okay, so the product rule states that the first factor times the derivative of the second factor plus the second factor plus the derivative of the second factor. So applying that one, we will have this one, and then we get the derivative of 1. So first times derivative of second plus second times derivative of first. And then we get the answer. So x, the derivative of y is simply 1 dy dx. And here we have the derivative of x is 1. So we will have this expression. Okay, x times dy dx plus y times 1. Okay, simplifying. So we will have x dy dx plus y is equal to 0. And then again, solving for dy dx, we can transpose y on the other side, and then we divide both sides by x. So this will be now the value of your dy dx. Did you follow? Okay. Okay, let's have this example. Find dy dx given that y cubed plus 2y squared minus 3y plus x squared is equal to negative 2. So again, the first step is to get the derivative of all the terms. So we'll have this one, the derivative of y cubed plus derivative of 2y squared minus derivative of 3y plus derivative of x squared is equal to the derivative of negative 2. So for y cubed, the derivative will be 3y squared, and then attach dy dx. For 2y squared, we will have 4y dy dx. And then for 3y, we will have minus 3 dy dx. And for x squared, we will have 2x. For the derivative of negative 2, we have 0. And then, second step, solve for dy dx. So these three terms contain the dy dx. So we can isolate this negative positive 2x on the other side. So that will give us this one equals negative 2x. So again, since this one contains the dy dx, so we can factor out dy dx. So that will give you this one. So dy dx times the quantity of 3y squared plus 4y minus 3 is equal to negative 2x. And then solving for dy dx, we just simply divide both sides of the equation by this expression. And our final answer will be this one. So you have dy dx is equal to negative 2x over 3y squared plus 4y minus 3. I hope you follow the procedure. Okay? Okay, this time let's have the higher derivatives for implicit function. Okay, let's have the second derivative of 4x squared plus y squared is equal to 16. We already solved for this one in the previous example, and our answer is this one. dy dx is equal to negative 4x over y. So this is the given, and this is the first derivative. Okay, remember these two equation or expression because we will be using this one as we solve for the second derivative. Now, we know that to get the second derivative, we have to get the derivative of the first derivative. Ito. And since this one is a quotient, we will apply the quotient rule for differentiation. Okay? If you still remember, we have this symbol or acronym. So the high refers to your numerator and low refers to your denominator. So that is equal to low times the derivative of high minus high times the derivative of low over low squared. So applying that one, so you will have y times the derivative of negative 4x minus your numerator negative 4x, so that becomes positive 4x, and derivative of your denominator y over y squared. So the derivative of negative 4x is negative 4 times y, so that will give you negative 4y. And for the derivative of y, we have 1 times, we attach the dy dx, so that is 1 dy dx times 4x, so that gives you 4x dy dx over y squared. Did you follow? Okay. To continue, this is where we stop, and we still have here the dy dx. So we know that the first derivative is this one. All we have to do is, the next thing that we're going to do is to substitute this value here. Okay, so replacing this one by negative 4x over y, and then we multiply it by 4x. So when we multiply this one, we will have a value of negative 16x squared over y, and then plus negative 4y. So we have to add these two expression. So we have to get the LCD. That's why we have here y. So y times negative 4y, that becomes negative 4y squared. And then you have y divided by y is 1 times this one is negative 16x squared. Okay? I hope you can follow. And then we divide it by y squared, or simply we can get the reciprocal of this and then we multiply. So we will have times y over y squared. And simplifying this, we will have now this expression. Can you still follow? Okay, so next is to factor this out. Since negative 4 and negative 16 is you have here the GCF of negative 4, we can factor out negative 4, so that will give you the positive y squared, or negative 4 times the quantity y squared plus 4x squared over y cubed. Why do we have to factor this one? Because, as I told you earlier, you have to remember the given. This is our given. 4x squared plus y squared, we get the first derivative. This is the first derivative, and we are working on the second derivative. So since 4x squared plus y squared is the same as this and has a value of 16, we can replace this one by 16. So that will give you negative 4 times 16 over y cubed. And our second derivative now will be negative 64. So multiply this over y cubed. So this is the second derivative for 4x squared plus y squared is equal to 16. So this is the first derivative and this is your second derivative. Did you follow? Okay. Okay, let's have another example. Find the second derivative. This is the symbol of x times y is equal to 1. Again, we already solved for this one. And we have the first derivative, or dy dx is equal to negative y over x. Again, to get the second derivative, we will get the derivative of this first derivative. So, again, this is a quotient. So, applying that one, so you will have log your denominator x times derivative of your numerator, negative y, minus your numerator, so that becomes again positive y, times the derivative of the denominator over the denominator squared. So for the for the derivative of negative y, that is negative 1 dy dx times x, so that will give you negative x dy dx, and here you have the derivative of x is 1 times y, so you will have y, and then we copy this one. Okay? Did you follow? Okay. So let us continue. So we have this expression. And then the next step is to remove dy dx. Okay? We just simply substitute this one by negative y over x. So we will multiply negative x times the value of dy dx is negative y over x. We can cancel x and x. And then when we multiply negative times negative y, so that will be positive y. And then positive y plus positive y, that will give you 2y over x squared. And this will be your final answer. This is the second derivative of x times y is equal to 1. Did you follow? I hope so. Okay, that ends our discussion for today. Thank you and God bless you.